Okay, good evening everybody at CocoaHeads in Q42 in The Hague. Very welcome, and I hope you had a lovely dinner. So thanks Natalie for arranging this, and Rens too. So who of you did not go to a CocoaHeads before? Okay, a few new faces. So normally we organize a monthly meetup. We have a fixed format of 2 speakers. Unfortunately, this time we only will have 1. So if you're up for a talk, everybody can present at CocoaHeads about things they are working on or would like to show others. We are part of the international CocoaHeads Meetup, and we discuss anything mostly Apple related, backend APIs, and front end, of course, building apps. So we have a couple of sponsors that make sure that we can actually keep the videos up and running and recording. So Marco is over there making all the recordings happening, and you can see them back in our YouTube channel or online in the TV app. We have a apparel shop, so basically you can buy any sweaters, t-shirts that you would like. I'm not wearing mine today, so sorry. The agenda for today will be a presentation by Rens about guiding the golden age, rebuilding the indoor navigation for the Rijksmuseum. So I'm really looking forward to this. But before I give the microphone to Rens, I would like to give the microphone to Natalie. And please give her a big applause, and thanks for organizing, guys.
Thank you. I'll keep it short. So again, welcome at Q42 at this CocoaHeads Meetup. I'm Natalie. I work at Q42 as a people and culture person. Just to give you a brief introduction at what Q42 is, we are a software development company. We build, as the slogan says, digital products that make the lives of people easier, quicker, and more fun. I usually do this in Dutch. Sorry if that wasn't so smooth. But that's really what we stand for. Just make awesome digital products like the website of the Rijksmuseum. We also do a lot of apps, Android apps, iOS apps. And we also sometimes just build other digital products for our clients, like tooling. Just they come to us with a problem, and we just love thinking of a digital solution to their issues. So there's a bunch of our iOS engineers here today, like Rens. You can recognize them by their hoodies or shirts. And of course, now you all know me. So if you have any questions, then just tap us on the shoulder and enjoy.
Ja, je mag gewoon dan werken. Well, oh, it's not full screen. So yeah, welcome to Q42. Natalie has introduced Q42 for a second. I'm going to be talking about rebuilding the indoor navigation for the Rijksmuseum. Let me first introduce myself actually. I'm Rens Verhoeven. I started in April at Q42, and in May I was immediately tasked with finding a new wayfinding solution for the Rijksmuseum app. And that is what I want to talk about today. For people unfamiliar with the Rijksmuseum app can be used in the museum itself to get an audio tour of all the famous paintings, but also to create your own tours of paintings you want to see and get information about. There are also hidden details about paintings in the app as well. Q42 started working on this app in 2018 after doing some more work for the Rijksmuseum, for the website, for the web shop, and also the recently launched collection online, in which you can see the entire collection of the Rijksmuseum online. And we created this Rijksmuseum app with wayfinding in there. This wayfinding was built with a partner, but there were some issues. So we had to get creative again and rebuild the wayfinding in the app. And this will be the final results of that wayfinding that we're going to build today. It's actually already built, but I want to give you a bit of an introduction on how we build it and how we actually got the data for building this wayfinding. So we'll get to we'll get to the original solution for the wayfinding. The original solution for the wayfinding was using the very cool introduced eye beacons that Apple introduced. It would show off the current location of the user on a map. It would be a great experience because the user wouldn't have to do anything. It would constantly show the location. You could easily find your route to the start of the tour, to any painting you wanted, to the toilets in the museum, to the shop in the museum. You could basically do everything. It would work great. The location was working great. And there were definitely no challenges. Well, no. As some of you might know, these are iBeacons, and they aren't looking happy because iBeacons and the Rijksmuseum didn't go so well. So with the Rijksmuseum is of course a historical building that comes with some challenges in terms of not being able to place everything where you exactly want it. You do want iBeacons in plain sight for the best reception. That wasn't a possibility. So they had to be hidden in stairways, they had to be hidden in air vents, they had to be hidden on top of walls. And this created all kinds of issues, especially the iBeacons on top of walls. They would cause you to jump between floors, which it was, you were on the same floor, but suddenly you were on the top floor, and the painting you were standing in front of turned into, oh, route to this painting. That's not a great solution. While that was being optimized by the third party also decided to just give up, sell itself to a different company. The original team gets dismantled, and we're left with a solution that doesn't really work. Also, there was the issue of bad cellular reception within the museum. This is also caused by it being in a historical building. They can't place Wi-Fi access points in great places. The cellular reception isn't great. So all the routing also needed to work offline, but it didn't work so well because they optimized a lot on the backend side of things, and things weren't going so well. Then there was also the concept of the iBeacons maintenance. Because they were on top of walls, they were inside air vents. The maintenance people from the museum constantly kept changing batteries, had to go into air vents, had to get on top of walls, which was just a really big hassle. Next to that, it was also not wheelchair accessible. It would constantly route you over stairs. You didn't know where any elevators were. So if you were in a wheelchair or you had some other impairment, you couldn't navigate the museum that easy. So we had to get to a new solution. Apple Indoor Maps. That's one that some people might know. It's a service that is offered by Apple, which allows you to have an indoor map. You actually create the indoor map yourself. You upload it to Apple. Apple will then give you a survey app, and they will tell you, go in a zigzag pattern in all the rooms. It will capture some RF signals, and it will tell you the exact location of the user using the CL Location Manager in your app. A great service, would be a nice solution, but there were some issues. Again, the Rijksmuseum is a historical building. It has a lot of fire safety code. And doing the surveying required a lot of people, required the museum to be opened at night. All the doors needed to be open, which is a fire concern for all the painting that are in there. And on top of this, Google has offered a similar service in the past, but it's sort of shut down. They no longer respond to any emails, so it wasn't a great solution. We needed to find something else. So we basically went back to the basics. In most museums, you will get a device that will ask you to enter a number in order to get an audio story that's related to the painting or the artwork you see. That's what we wanted to use for the Rijksmuseum. So instead of already knowing your starting position, we would ask you to either say, oh, I'm at the entrance hall, or I'm in this gallery, or I'm in that gallery, and start from there. That was the basic start of finding your way in the museum. That still came with some more complications, because we had a map that needed to be made. This map was already made by that previous partner, and we could create the entire map again. Would be very time consuming, not a very pragmatic choice, so you want to see if you can reuse some stuff. One of my colleagues at Q42 decided to reverse engineer the SDK, found out that there was an API call that was returning a lot of JSON data, and nobody will probably know what this JSON data is, except for that there are coordinates in there, so it has to do something with location. So we now have data. What is this data? In this data was an array of 1,700 features. We still didn't know what features were, and after digging a little bit around, we found out that it was actually a GeoJSON file. GeoJSON is a standard for geographical information and could be used on maps and all that kind of stuff. So the next step that actually my colleague Matthijs came up with is looking at the MK GeoJSON decoder that's inside the MapKit framework, seeing if we can throw the data into there, and suddenly we had data. We had something that was familiar to me. The MK polygon came out of the MK JSON decoder because in the previous project I needed to draw a line on a map, which is an MK polyline. Made sense, MK polygon. I know that kind of data. I know how to work with it. So I went ahead, digged further into the data, and actually created a small app that transformed a map with all of these features drawn with a little bit of transparency. But if you look at this map, there's no transparency there. You can see the rough shape of the Rijksmuseum, but there's no transparency, indicating that there's a lot of data all on top of each other. This had to be the data that was drawing the map. From this, we continued on with this data. But that meant exploring the data. We have data, we have a rough map, we see a rough shape of the museum, but what is a door hook? What is a heavy route vector? What is a invisible stairs? What is a dotted wall? What do all of these data points mean within the data? We had to explore what all of this data meant. So I further developed a simple Swift application in Swift UI, added the way of showing the color in there for certain elements, and then we went on a big adventure to the museum and just explored all the real-time data in the real situation. We saw where the room of limits were, which were of course some maintenance rooms. Well, we also saw the invisible stairs, which were actually not stairs, but they were just small slopes that could easily be done with a wheelchair, but somehow were called invisible stairs. We now have data. We now know what the data means, so we get to actually drawing a map. Then first comes a question. Do we go with a UI scroll view or an MK map view? UI scroll view would be a sort of obvious choice. We're drawing an indoor map. We don't need any details from around the surroundings. We don't need roads. We don't need any of that. So a UI scroll view would be easy. We could pan, we could zoom, would be easy to draw on, and we wouldn't have to deal with the original map tiles or the cost that comes with, for example, using Google Maps. However, it's not optimized for performance until you go digging into things like CA tile layer. It also means you have to use a relative positioning, so you would have to translate coordinates from the top left of the UI of the UI scroll view to any position within that scroll view. So MK map view was a more serious choice. We could do positioning using the coordinates. The user can still pan and zoom. We can get the user's location on the map if we ever want to do that. It's performing because it's tileable. However, it does still use a lot of data. It still loads the map tiles, and it's not the best in an offline situation where you need cellular reception. However, we still went with MK map view. MK map view was in this case the most obvious choice. And drawing the shapes on there was just as easy as just adding an overlay directly from the MK GeoJSON decoder, so the GeoJSON. Now, some people might ask, what about SwiftUI's map view? We could not use SwiftUI's map view because the actual drawing of overlays was introduced in iOS 17, and the app still had to be backported to iOS 15. That wasn't an option with the SwiftUI map view, so we decided to go with a MK map view wrapped in a UI view representable for the test app. For the actual app that was still mostly UI kit, we went directly with the MK map view. So now we actually need to draw on that map. First, we need to prepare the MK map view for actually taking in these shapes and taking in any annotation that are actually in there. So we need to set up a map view, and we always have to assign the delegate. Since we need to provide an annotation view, we also need to provide a renderer for an overlay. Next to that, we need to split the GeoJSON, or the features that come from this GeoJSON, into shapes and annotations. There are only MK point annotations in the features list, and there are a lot of shapes in there like MK polygon, MK polyline, and MK circle. Those need to be separated into separate categories using just a simple filter function. And from there, we first go with the shapes. We use add overlay, add the simple shape to the map, and we have a shape. However, the order of these add overlay functions, or the add overlay function, matters. The first shape to be added is the first to be called by the renderer and the first to be rendered on the map tile. For the museum, this means that any shapes representing the side of the building need to be drawn first, then come any rooms, then come any pillars. There were some additional functions that we needed for replacing overlays, but also inserting overlays at an index, but I will get to that. With having an overlay, we now had to implement that renderer delegate. So you have to implement a renderer. MKMapView doesn't supply the renderer by default. However, there are default renderers to implement, but you still have to implement the delegate method yourself. So you easily implement the MK polygon renderer, the MK polyline renderer, or any of the specific renderers, like there's a gradient line renderer. Another two that you might notice in this screenshot are the MK multi-polyline renderer and the multi-polygon renderer. Rendering all of this is expensive. There was a cutout. Is my audio back? Okay, good. It's still very expensive to render everything. So you want to use a MK multi-line and multi-polygon in case you're drawing the same stuff a lot of the time in the same style. So the entire building shape might be several polygons, but you just draw one MK multi-polygon with all those polygons inside of it. They all have the same style and you get a great performance. That's the adding the shapes to the renderer, or adding the shapes to the MKMapView, but then we get to the renderer. And the renderer, some people might not directly say or directly know what it is. It's basically just the fancy version of a drawRect function that we find on UIView. It simply draws the shape and does that in a specific map tile of that map. MK provides some of those default renderers that we saw before, but both the overlays and the renderers can be subclassed to provide additional details. You can already use the properties on these renderers to adjust details like line width and the color. However, in some cases, you might want to change more. I will get into that for a second. Because one of the things we need to do in the Rijksmuseum is override the renderer that we were using for the lines that surrounded the building and were drawing walls within the museum. One of the default behaviors of the default renderer is that the line will always say the same width regardless of zoom scale. It's hard to explain, but it means that it might be 8 pixels when the map is fully zoomed out, but it's also 8 pixels on your screen when the map is fully zoomed in. That's the behavior that looks a little bit weird if you look at it for the museum. You will see that suddenly the pillars that have lines around them become just large black blobs. The fix for this is simple. You override the apply stroke properties feature within the renderer. You call super, and after that, the context will have the line width adjusted for the zoom scale. So you simply replace it with the line width that you wanted, and it's now always at that line width regardless of the zoom scale. So it doesn't no longer changes the scale when you change the scale of the map. Another one didn't come up within the Rijksmuseum, but it's an interesting one that I did for another app, which is the Amsterdam Light Festival app. You have to create path function, which simply creates the path based on the polygon or the polyline that you pass into it. And a polygon or a polyline is basically just a set of geographical points in a certain order, and they have to be drawn into a certain order in order to create a shape. However, sometimes you might want to tweak this shape. In this case, the screenshot is really simple. It's creating the same shape as iOS would create. However, if you would like to smooth out a line, you could easily do that with this function. just add some quad curves to it, and you would have a nice smooth line, like for example in the Apple Fitness app. Then there is the last function that goes really in depth, and that's the real draw function. You can override that draw function. It takes in the map rect, it takes in the zoom scale, and it takes in the context. Within that context, you will just draw the shape. But here you have to keep in mind that you only draw the things that matter within the map rect. The map rect is simply a MK map rect, which you can easily translate to a CG rect, and just get all the paths in there, and everything that's outside of it, just discard it, because the system will discard anything you draw outside of that map rect as well, so you're losing performance. This is one that I actually used in the Amsterdam Light Festival app to draw a route with a lot of arrows on it to show you in which direction to walk. So that's it for the shapes. Now we only get to the simple annotations. Some people that have worked with MK Map View are already pretty familiar with annotations. You just call add annotation, you call add annotations, implement the view, or you register the view just like UI table view, and then implement a view and return it using the DQ function from the delegate. Now you have your annotations, and you're showing annotations on the map basically. Within the Rijksmuseum, you will get to this point then. You now have a map. On that map, we can see the individual floors, which was a property on the features. And you see the walls, because they're drawn in order. You see the pillars, you see the staircases, and you see all the little annotations for all the paintings that are placed in the map right now. However, we're still seeing streets. And we're looking at an indoor map. We don't want an outdoor map. You don't need the context of the street that's behind the Rijksmuseum. It will just pull you out of the Rijksmuseum, out of the Rijksmuseum experience, the Rijksmuseum app, so you want to hide those. That's where one last trick comes in with MK Map View, and that is the MK Tile overlay. It's a specific kind of shape. It's actually part of the MK Polygon series, and it's just an overlay that can actually replace a map tile. You most of the time have to override MK Tile overlay, set the can replace map content to true, and this will completely replace the map content that Apple would normally draw for the map tiles for the roads and stuff like that. What you can also do with the MK Tile overlay is supply a URL template and completely replace the tile with just a simple image. This is, for example, used by a lot of apps that draw their own fancy maps, like, for example, the Efteling. They would draw their own map. You can just easily get the map tiles based on an XY coordinate from a list of URLs, and then you have your own custom map. With that, after implementing that for the Rijksmuseum, we have now a hidden background. The map tiles behind us are still being fetched, so the data is still being used, but since they're vector-based tiles for Apple Maps, they're very easy to draw. They are not actually drawn, and it's just a gray background at this point. So now we have a map. But this map still doesn't tell you how to get to the Night Watch. For that, you still need wayfinding. So we need to start navigating on this map. That's also where a second issue came again, because we need data. You can't easily navigate on a map. You need some kind of nav mesh. So we went poking around in the SDK again, didn't really find it. Turns out that a lot of the routing was done online, so we couldn't actually see the data. We jumped onto a call with the partner, and before we could say anything, the partner said to us, "Do you want a database export of all the data?" And we were like, "Yeah, let's do that." So I looked at the data in the database and exported a JSON file of what was known as navigation nodes in the database. These navigation nodes I then plotted onto the map, and you see that a pathfinding map appears. People that are known to game development might know the pathfinding maps or the navigation meshes. And this is a lot of the data we can use for pathfinding and finding your way within the museum. This is the data that the app was using to do the offline routing. And with this, we had navigation nodes and navigation links. The navigation node was just a point on the map. The navigation link was a point to the next node on the map. From here, we started looking at doing the pathfinding. I quickly realized that I just needed to use A*, which I already knew from some game experiments. I asked ChatGPT to generate the AI or the A* pathfinding in Swift. I tweaked it with the data that I needed for the Rijksmuseum, and I got pathfinding working. Still, there were some extra challenges we had to do with this pathfinding, because we still wanted to make this wheelchair accessible. However, there was another issue as well. The Rijksmuseum has really nice monumental stairs. These monumental stairs are wide, they're great to use, but they're somewhat hidden. There are some extra stairs around the elevators that are very easy to get to. For basic pathfinding, you would choose those stairs, but that's not what we wanted. You want the monumental stairs. If you're with a group in the Rijksmuseum, you want to travel over those monumental stairs. They're wide, they're beautiful. You don't want those very narrow, small stairs that just wind around an elevator. So we needed to apply a cost to each link. Each link between a node needed to have a certain weight factor, and that weight needed to be increased for the smaller stairs and decreased for the bigger stairs. This way we could navigate nicely to the good location. And the second one was that we needed to have some kind of accessibility. So on each of these links we had a property that said it was either a flat route, it was an elevator, or it was stairs. If you would choose in the app for using elevators, we would filter out any stair links. If you were going for the stairs, we would filter out any elevators. That way, the routing would always take place over stairs, elevators wouldn't get crowded, and it would be a great solution for people that had trouble walking through the museum. That's how our basic pathfinding got to working. But still, you're not a node. You are not a node, the Night Watch is not a node, paintings from Frans Hals are not a node. Nothing is a node. We had to go from a painting to a node. So we knew the location of each painting was assigned a number, and each gallery is assigned a number. From this number that you enter, we translate it to either an artwork or a space, and from there we have to get to one of these navigation nodes, because you're traveling between navigation nodes for the pathfinding. So what we do is we simply find the closest node for that painting within the same room, which was very important. And from there, we actually start routing you around. So in this example, you can see that the Night Watch doesn't have a point directly attached to it. We navigate to the first point nearby, and from there we take the route over the monumental stairs downstairs. That meant that the wayfinding was now working. We had a pathfinding solution. You could get a route to the museum, and we had a nice viewing of that route. We implemented the new design. We added some instructions in order to make you get on your way. However, you're still not finding your orientation because you're looking at a line on a map. You don't have your real location because GPS doesn't work in the museum. Even the bearing of your compass doesn't really work in the museum. So you had no orientation. What do we do as a solution for the orientation? For this, we figured out before we actually started developing, we figured out that we wanted to have 360-degree photos in there so you could see the line in the space around you. So we accomplished this in the app with a really nice 360-degree viewer. Now, this 360-degree viewer is very easy to implement. If you would look at the AR kit, you could just draw a spear, turn it inside out, paint an image on it, and you're done. However, now you need to add a line. And that line also has to disappear with a new instruction. You need to move to a new image. It was a lot of work. Q42, luckily, has a venture underneath it called Micrio. And Micrio has a full WebAssembly implementation of a 360 viewer. It also has the CMS to implement these photos. It also has embeds like the lines that you can see on top of it that we could easily manage the lines on top of an image and show it to you in the real space. But we don't like web views. We're iOS developers, we want something native. Web views never look good, they never work well. It's always a janky experience. So we just use them to augment the navigation, and instead we used JavaScript and message handlers to communicate with Micrio, because, well, it's a venture of ours, so we can make these changes. And using JavaScript, we could easily navigate to the next photo, hide arrows, show arrows, and with the message handler, we got messages back from the web view to know when it was loaded, when it was moving to a new direction, and we had a working prototype. Each node within the navigation graph would be assigned a 360-degree photo, or not technically each node, but to make it simple, each node would have a 360 photo, and each line would contain the ID of a line within Micrio. This way we could have the entire solution, and we would get to an entire wayfinding from getting you to from the multimedia desk to getting you actually into the museum and finding your actual location within the museum, walking to your tour and doing everything you want. And that was actually my complete talk. So if there are any questions, feel free to ask them. Otherwise, we can. Thank you.
Questions,
Hi. Does it work? Yeah. So you make a map view, a real map view. Can you limit the scroll range or the zoom range for the map view?
If you there's a very extensive camera property on MK Map View that you can use to actually set a boundary and also to set a zoom limit to actually set it to a certain region. There's still the bad detail that if you zoom out really far, the zoom region is connected to the just the normal horizon, and the museum is at an angle. We changed that angle within the app, but if you zoom out, that means you're going between points, and it looks a little bit wonky, but it works great. It was actually the same with the Google Maps solution that the previous SDK was using, so it was fine in that case.
So you can scroll away to
yeah,
nothing.
you can scroll away, but you won't get away from the museum. So at one point it just limits and it doesn't go any further. You don't have to implement that limit yourself, just supply a map rect, and within there it will just limit your movement.
Gotcha, thanks.
Any other questions?
Yeah, hi. So am I right in assuming that you then didn't solve the actual location problem?
Yes. We decided to go back to those numbers. It doesn't really show the user location because at this point that's really hard to do. We could use the Apple indoor maps that would work great for iOS users, but there's also a big majority of Android users in the Rijksmuseum. They would not have that solution. And there are also some loan devices that you can get from the museum. They actually run a special version of Android, and they would also not have the user location. So we would then have to manage two solutions that both might not work well, because with the indoor maps, you have to submit a map and then survey the entire building before you can actually see if it works. So we decided, like, let's go back to the numbers. And if something new pops up that's a better solution, then we can always like try it out and build on top of this. We now just have a really good base.
Thank you. Okay. When regarding drawing all of the overlays, you said that if you draw, you said something about the performance. You said if you draw too many of those nodes, even if they're not within the map itself, there would.
Yeah, if you, there are two things at play. If you add an overlay, for each overlay, it will make a new renderer and call that delegate separately. So you create a new renderer. You can't reuse those renderers. So you would constantly be rendering something. There is a performance hit to that because you constantly have to instantiate a renderer. It will call the functions to create a path. It will calculate it from the map rect, which is the coordinates, to a CG point, which is the local coordinate space for the screen, of course. And that just gives you a penalty. If you then just combine the polygons and polylines that all have the same style, for example, all the walls within the museum, they're all a black line, they're all the same width, you can just combine them into the MK multi polyline, add that as one overlay to the map view, and that will only call one renderer and it will only call one draw function. The second thing is, if you implement a custom renderer, you have to make sure to respect the map rect that you get for the draw function. If you don't respect that, you're drawing stuff that the system will just throw away for you, because it will only like it will clip the path to that rectangle, but it does the clipping after the draw function, so you still get a performance hit.
Thank you.
Any other?
So now you have quite nice map, and probably you have to reconsider about iBeacons, because iBeacons give you one really nice opportunity. So you put your phone in the pocket, and when you come to close to a night watch, it will send you notification. So you come to your position. Understood what I mean? And also, you can, I know what you mean, it's not precise technology, it's all technology. But you can put, how it's called, signal level, right? To really small, so it will works in gauge, in corridor, only. And now with your maps, you don't need precise position, actually.
No, that's true. But still, you're limited to where we can place these beacons, and they can't always be in ideal position. There used to be paint with lead in it. That's still in the museum in some places. That will block a signal, so it will reroute a signal. Or you would have to place the iBeacons on top of a wall because they can't be with the painting. If they want to place it next to a painting, or they want to place it with a number plaque, they have to get approval from several instances or governments in order to just place that single iBeacon. So they have to place it somewhere where it won't damage walls, it won't be inside of the user. So they're limited to air vents, they're limited to putting them on top of walls, they're limited to hiding them in little boxes on the floor. And that really hurts signal and gives some issues when you go between floors. Because some of the floors in the Rijksmuseum are actually still wooden floors. So signals travel through that really easily, where we're now used to concrete floors, where a signal is slightly blocked and indeed decreases in range. So it's still not an ideal solution. You could still, for bigger paintings like the Night Watch, probably figure something out to get you a notification. But that's things we can build on top of this basis indeed.
Any other questions?
I was wondering, do you store your GeoJSON as an asset in the project?
It is stored locally, or it is cached locally. There is a local version that's shipped with the app, but it can also fetch a new update from the server and keep that stored. Okay. So in that case, there's always one available, even if there's no good Wi-Fi connection.
Okay, so if they change the paintings around, or there is a renovation, you can keep it
that's also the reason why a painting is not a node, because the paintings can move around, and that would constantly mean we would have to change that pathfinding map, while they now can just easily move a painting within Scribble Maps, which is the editor we use for the map, and we will do the rest of the calculation offline on the phone.
Yeah, I missed the part how you integrate the micro library into your app. Does it work as a web view, or you find a native solution?
No, we actually, it's not even a library. We literally just call a URL for Micrio that's specific for the Rijksmuseum. And we can interact with that web view over JavaScript. Mm-hmm. So we have the ID of the photo that needs to be shown. We just pass that ID over JavaScript, and Micrio does the rest and navigates with a nice animation to that new position. So it's really a custom-built solution, but it's basically just a web view that we load, and we just talk back to it with JavaScript, and it talks back to us with a message handler.
Yeah, got it. Thank you.
In addition to a previous question, but how Micro knows what is the user position at the moment?
We tell it which picture to view. So the pathfinding is all done locally on the phone. We do that all offline. And within that, we get a list of nodes and all the links between those nodes. And based on that, we also generate instructions, which are also made locally. Connected to the point that's related to that instruction is then that Micro ID, and we show that photo. Not each node has a Micro photo. If it doesn't have a photo, then we always revert back to the map. So you can just view it on the map. For example, this happens when you're in a staircase and you're just on top of stairs. We don't necessarily need a photo there. We can just show you, oh, you need to go up these stairs.
Thanks.
Additional questions? Then I actually have two.
Oh, you have two?
Yeah. So based on this, would it be possible to reproduce the experience of walking through the Rijksmuseum with some glasses?
Not necessarily with these photos, because they're really just photos, and you would be like warping between spaces, which isn't ideal with glasses. You would rather have like a more interactive video or a 3D space in which this is done.
Okay, and the second one would, I can imagine that if there's any company that want to reproduce an indoor environment like you did here, then you would be more than willing to tell people more about
how it's done, what we did exactly to make it all happen.
Very cool. Okay, thank you very much, Rens, for your talk. And I think this was the only talk, but it doesn't mean that there's nothing to do. There's a room full of interesting people all doing amazing stuff. So if you want to talk to Rens or want to talk to any other people, please do. If you are willing to do a presentation, please come see me and Marco if you think you have a host in order to host the next CocoaHeads. Same two people at the moment. And then thank you very much, Rens, for the presentation, and Q for hosting us. And see you next time.
Ask someone with a Q42 hoodie on or a t-shirt, and it will help you out.
you.